So in that case, 3, 4, 6, and 7 are those the location have what? 1, right? And then those are the locations having 0. From what I see here, what was the regulation? What was the rule? The rule says, we try to group as many as 1 we have, and it has to be 2 power something, right? So I see here that, there is a group, right? This is a group. This is a group 1. Do you agree? Now, this is also another group. This is group 2, right? What we're gonna do with this guy? Do you have an idea what should we do?
Just group it by itself.
You think so?
I thought we were able to do that before, for the next NOR.
No, you're right. You're right. But
okay,
we are doing it in case we cannot find a neighbor. But I have a news for you. Yeah. This K map is like the Earth. So have you seen the Earth map? Right. You see United States here, and you see Russia there, right? And then you will just think about from the history books that United States bought Alaska from Russia, but then you will say, how does this come? Alaska here, but United States there. You know why? Because if you fold it like this, you will find in their neighbors. So let's translate what I'm saying. Basically, this one has to be grouped with this one because you fold it like that.
Oh,
see, good trick, right?
Interesting.
Okay, so this is actually group 3. We're gonna practice a lot on this. Okay. Does it make sense? Yep. Now we can come into the conclusion saying that we have group 1, or it was group 2, or it was group 3. Right? You guys will help me. It's not really hard, right? Somebody tell me group 1, right? It's pointing to what? Huh?
It has X.
An X. Is he right, guys? You think he's correct?
I think it's XY.
Group 1?
Is that the blue group?
Yes.
Yeah.
So you think it's XY, right? Somebody else. Is she's right? He is right, or what?
I think it's X complement and Z complement.
I thought it was X. I say it's XZ.
Okay, Andrew, what do you think?
Oh, I thought you were just asking for step by step, but yeah, it's XY. It's XY.
It's an XY. It is XY. Why? Let's see if it's XY and Y, right? Now, this is the group, right? Horizontal is looking to what? Looking to what?
X.
X. So, at least, we know that it's X, right? Vertical is looking like this, right? So, looking to what? Z is changing, right? So, Z is out. Which one is still there? This one, 1. Belong to what? Y. That's why it's Y. That makes sense?
Yep.
So they both have to have 1 in order for it to be Z or Y?
Yes. Think about it, right? Y plus Y. Y always Y. What the output will be? Y, right? If you want to write it, it's basically like this. It's Y, ORed with Y, ended with Z complement, right? This guy is 1, and this guy is Y. That's why it's Y. Make sense? Hello?
Crystal clear.
Yes, sir.
Because, every single, what is the relation between midterms? The only relation operators we are using between the midterms is OR, right? So this or this. This or this. That's why, we are ORing between of them. Okay. Now we need to get into the group 2. So somebody tell me what group 2 will be. How gonna look like?
YZ.
YZ, yeah.
It is YZ. Do you guys think he is right?
Yes.
Yes, he's right. Yes.
Because you're looking at the vertical, right?
Yes, you're right. I'm just trying to trick you. You know, that's happened. You know, let's go to group 3. Group 3. Horizontal is what? X, right? X, right? Vertical is this one and this one, right? So in this case, you can just write X, ended with Z is a common here, but it's 0, so it's complement. So this is the final optimization. You cannot do more than that. This is actually the full optimized.
Sorry, do we need to do anything for the Y complement?
Where?
Oh.
This is 1. This is 0.
Yeah, I gotcha. So
You
it
know, when you
cancels
say
out. If it's
change, you know, then you say bye-bye.
if it's the same, then it's a
Then you
complement.
take it.
Got it.
But you need to know why, right? Because, you know, basically you're taking this with this together, right? So basically, you know, it's a Z complement or with Z complement ended with Y, and this is Y. This Y complement, this is Y, right? This is what 1. This is what Z complement. That's why it's Z complement.
Makes sense. Yeah.
Okay.
So
Yes.
Can you please re-explain why we don't take in consideration the one at the corner?
Which one?
On the far left at the bottom, the X.
This one?
No, on the other side.
This one?
Yes.
Okay.
Can you please explain why we don't?
Why you didn't take it by itself, right?
Yes.
Because that will add more gates, right? That's not called optimization. What is the target of the K-map? Full optimization. You can give me an answer, but this answer will not be filling the target. You know what I mean? Digital logic, there is infinity answers. But what is the best answers I'm looking for? Optimization, optimized. So in math, you guys have one answer, right? But here, you know, we have infinity answers. But you know, which one is aligned with my target? The optimized, right?
Okay.
You understand my point?
Yes.
Okay. Anyway, more questions?
So the K-map's like a ring, right?
Yes, it is. It is like a ball, basically. You can consider like a spherical thing. Anyway, let's have more to practice. So let me see. What about this? If I give you a K-map like that, boom, 1, 2, 3, X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 3, 2, 4, 5, 7, 6, right? Then I will fill with a different color. What do you think? This is cool, right? What should you do with this? So rule said, you know, once it has to be 2 power something, right? So 2 power 2, it works for us, right? I see here ones are neighbors, so this is a group. This is group 1. Then these 2 ones, what should I do with them? I look to the higher number. So nobody will come and tell me, you know, oh, we're gonna group them like that. 1 second. That's not sufficient. You need to group 2 more because, you know, they are neighbor to them. So in that case, you know, you can just remove this, and then, you know, you say, you know, I'm grouping this with this. And this is group 2. So did you get the point? We got this part? If you just said, oh, 1 and 1 I didn't use, right? So let's just group them. And, you know, it's a spherical thing. So, you know, I'm folding them and, you know, this is a group, right? still you didn't make full optimization. So the full optimization, oh, I have one here and I have one here, even though I used them before in a group one, but still they're neighbor in a vertical manner, right? So I take this here and take this here. So that means 1, 2, 3, 4. So I group it in 4, right? So in that case, I can come and say that, the output of this will be group 1 ORed with group 2. And let's do it together. So group 2, what will be the output? Group 2.
Complement.
It will be Z complement.
Z complement X complement?
Why X complement?
Because you have a switch in X on the top as well.
No, let's see. I'm in a group 2, right? This is group 2, right? So let's go now. Horizontal, it's X ORed with X complement, right? It's gone, right? Now vertical, I'm going like this, I'm like that, right? Now, here is 0 in Y, here is 1 in Y, out. Here is 0 in Z, here is 0 in Z, so they're actually common. So that's actually Z complement. Make sense? Hello?
Yeah.
Basically, no, this one, it used to be like this. X complement ended with Y, and Z complement. Then this is 1, this is 1, this is Z complement. Right? Let's have group 1. So group 1 is looking into this direction, right? So that means it's going to be X complement. Because, if you go up here, 1, 2, 3, 4, all of those guys will take each other. So they're going to go away. So you are just looking for similarities. Just put it like this. I'm looking for similarities. If I find something similar, that will be my output. Sounds good?
When does it ever be, can it ever be Z and not just Z complement?
This is Z complement coming from the group 2. X complement is coming from group 1. This one.
Yeah. Oh, can it ever be just Z? Does it always have to be Z complement?
How are you gonna make it Z?
If it were in the middle 2, in the middle 4, those would be Z. Not on the outside one.
Z, this guy. Right?
That's why, right?
Huh? No. Wait. Here, look.
I'm confused.
No, don't worry about the confusion. Anyway, X, Y, Z. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, right? Look carefully, right? Here's 0, right? Here's
I'm confusing I got it.
So this is what Y complement.
Yes.
Great.
Okay, if they're both 0. Yes.
Yes. Okay.
Okay.
Now, this is 1, 1. So here is what? Z. All right? Here is 0, 0. So those gonna be what? Z complement. Those are what? This is X complement and this is X, and so on. You know what I mean?
Yeah, I got it.
Okay. Anyway, how can you actually remove any confusion? Practice. How can you remove confusion? Practice. This is my only advice. What about if we add X to it? You remember the X from the last time? Don't care, right? When I say don't care, that means I can literally put it by my hand 0 or when I need it. That makes sense?
It's kind of like a wild card.
It's like a wild card, exactly. Yeah. This is my wild card in the Fisten. Have you guys played Fisten?
Yes.
I love Fisten. When you guys come back to the school, we can play together Fisten. Anyway, so look at this, right? I have here my K-map, right? 1, 2, 3. X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And here 0, 1, 3, 2, 4, 5, 7, and 6, right? X 1, 1, X 1, 0, 0, 0. Now what should I do? First of all, this X, right? Literally, I don't need it. Why? Okay, I can have it or I don't want it. You know, it's up to you. One of the way I can do it, I can make this guy equal 1 and I make this guy equal 0. You guys agree? Or the other option, I make this 0 and I make this 1. Let's see, right? 1 and 1, they don't have any neighbor to make them 4. Do you agree? So pretty much those are grouped. This single one, it
Wait,
can
Professor.
be, yes.
If you make the X on the top 1, don't you need to group all 3 of them?
If I make the X, yes.
No. The left one, the 0, 0 under 0, 0, you have an X there, right? If you make that a 1, do you need to group those 3?
1 second, 1 second.
Sorry.
Okay, then what happened?
Then you'll group the top 3, right?
Top 3 will be 2 power something. Give me the equivalency in 2 power something. So 2 power what? 2 power 0 is 1, right? 2 power 1 is 2. 2 power 2 is 4.
Oh yeah. Okay, yeah.
You get my point?
Yeah. Okay, got it.
Anyway, so now if I make it here 0, right? This group is fine, right? But this one, it can be by itself if this X is equal 0. This is not good. So one of the way is to make here 1 and make this 0 and take those guys together. And that will be a solution, by the way, right? So in that case, will be a group 2, and then you will come and say f as a function of x, y, z is equivalent to group 1 or it was group 2. Do you guys agree? And this, in this case, what group 1 will be? Group 1 will be x complement z.
Z.
Right? X complement z, and group 2 will be y complement z complement. That's a solution, right? But doesn't mean that, you know, I don't have other solution. What other solution? I can actually literally remove this and I put it 0 and I make this what? 1. Right? Then I can just go ahead and group this together. And that will be my alter group 2. So this is actually going to be group 2 like this, whatever. So I can say my second solution will be group 1 with group 2, whatever, right? So group 1 is still as it is. And group 2 will be what? Will be X?
Z not.
With Z complement.
Oh, no.
Why is it X and not X complement? Never mind.
Okay, so, you know, there are 2 solutions, right? But wait for a second. This solution is more fun. Why? Because this can be taken into X or what? Z. So I shrink the number of gates to 1 gate. But here, still I'm gonna use what? How many gates? 1 OR gate here, and then and 2 AND gates, and then, you know, 1, 2, 3 NOT gates. So here 3 NOT gates and 2 AND gates and 1 OR gates. Here, just one XOR gates. Make sense? So it depends on you. If you are in the lab and you don't have XOR, go ahead for this. If you are in the lab, you have a lot of XOR, go for this. And both of them will give the same answer. Any question?
So at this point, would you, as an input, there's no Y input, right? I guess.
Then I exclude the Y.
Mm.
Then Y is redundant.
Mm.
That's called optimization, right?
Gotcha.
And by the way, later when you will go to 3300, you're gonna, not even 3300, soon I will tell you some tricks on design actually. This is tool to help you to design your target in a lower number of gates. Why we are trying to build everything in a lower number of gates? Somebody can tell me why.
Cheaper.
Processing.
Why we are trying to use less number of gates?
Less
Faster.
processing.
Yes, it's not about processing. It's about power. Think about it, right? If I have 4 gates and all of those 4 gates, it has to be connected to the VCC, right? The source, right? That means the source will start what? Draining more current, right? So that means, you know, there is a power consumption. That means heat will be coming out. Then you have to cool it down. Cool it down, and still also power will be what? Consumed. At the end of the day, it will be very expensive for you. If you are building up a product, you have to look into how many resources on the chip used and how much power consumed, so you can make this chip more, how to say, more famous, so every customers will be in need on using it. Like, you know, why Raspberry Pi is very nice and everybody's using it? Because ARM, as a British company, have been acquired now with NVIDIA, the one who built GPUs. Basically, no, the idea, build something small, you know, distributed on the wide range of people. Maybe I can build you something very fancy, but it's actually consuming power. I will need like a nuclear power plant nearby the university to turn it on. Then, you know, it will not be feasible, right? That makes sense? Any
Yes.
questions so far regarding this part? So at least, you know, we know what is going on with the 3var K-map. Do you guys agree? And we also know about the checkboard, the, like, you know, the checkmate or mat or whatever you call it. I think it's checkboard. Yes, checkboard. So checkboard in this, and I did it in front of you before, is going to be 1 1 1 1. This is basically whatever A, B, C. So you're talking about A XOR with B XORed with C. If you make it like that, V, W, N, 1 here, 1 here, 1 here, 1 here, and 0, 0, 0, 0. That means, you know, A XNOR B XNOR C. Sorry, not A. Why A? V XNOR W XNOR N. Any question?
No.
So what about if somebody told you, here is my circuit. X 1 X 1 0 0. A, B, C. What are we gonna do? One is far from the other one, right? So that means, you know, 2 groups. Do you agree?
Yes.
Then you have to be tricky. Why? If you decided to make this 2x equals 0, then, you know, you are actually responsible on 2 groups, and those 2 groups will be involving all the 3 literals. Do you agree? So in that case, you would say this is group, and this is group, and then you will start doing it like a 0, 0, 0, 0, 1, 1, 1, 1, 0. So end of the day, you will say this is actually equivalent to A with B complement C, and they're gonna be A with B C complement, right? Do you agree?
Yes.
Which is end of the day is consuming to you A ended with B XORed with C, right? So then you have to check, what if this X will be 1 and this X will be 1? It will turn to be what?
XNOR.
It will be XNOR, right? So they're gonna be A XNOR B XNOR C. Then the only player here to define whether that this is really good solution or not is your implementation, and what is the critical path and which one is the longest. So that means which one will be quite fast and less resources. Do you agree?
But this will just use 2 gates, right? For both of them.
Yeah, but what is the weight of the gate? If I'm telling you this circuit will be built using 2 input NAND gates, then you have to convert everything to NAND, right? And then you will check the critical passes and the much power coming out of every single node. And from there, you can decide which one is the best, right? You agree?
Mm-hmm. Yeah, that makes sense.
See, we are building up now to make you mature designer. So you know what I mean? We learn the critical path. We learn, even though that you look like, why he's telling us critical path? Oh, why he's telling us this? Because, end of the day, this is just like, pieces together. You're going to put puzzles together to build the bigger thing, which is you are designer. Okay?
What's the difference between having those X's 0 and 1? Is it just convenient, or?
Those X, why we need X?
No, what's the difference between, because if we put 0 right there, we get the same thing as putting 1, correct?
Yes. But my question, it's not about giving or not. I'm talking to you about it's not convenient. The most important to you is how much resources you're using, and then how much power you are consuming, and then what is the longest time this circuit will take to give you the right outputs, right? So for instance here, right, this implementation is basically A ended with BC, like this. And this is the F. Do you agree? This is your XOR, and this is the AND, right?
Yes.
Okay. Now, my question to you, what about if I use this? That means, A with B with C, right? From far distance, we are using 2 gates here, 2 gates there, right? But I know from my study, when I work with you in the gate equivalency with using NAND, this guy, what the longest pass was? It was 3, right? 3 NAND gates, right?
Yeah, I believe it was.
Yes, it was 3. And this 2, right? So that means, this guy will be taking what? 5T NAND, right? This guy was 3, followed by 3, so that means 6, right? So the longest is gonna be 6T NAND, right? In that case, this is gonna give me answer faster. By what? 1 unit of the T NAND. But then it's a compromise. Maybe somebody will tell me, yes, I know that will be faster, but unfortunately, I don't have on my lab disk now, bench, and an XOR. I just have an XNOR. Then you know there is no way I have to do to XNOR. Now it makes sense. So there is many factors going into it. I'm asking you to make the design based on the what available gates you have in your hand, or I'm asking you to make the design with respect of the timing, and you are making the design based with respect of the power and so on. Okay, Luke? Any question? Do you guys want one more example for the 3 var, or should we move to the 4 var?
I think we're good.
If you are good, write good in the chat. If you are not, just say one more. Oh, I see some diamond here, you know. I'm gonna collect all the diamond and sell it, you know. Okay. Anyway, now we're gonna go into the last one from my view, which is basically it's called 4 var K-map. 4 var K-map. Why 4 var? So it's gonna be F, X, Y, Z, W. So I have 4 variables. So I have to make sure if I have a truth table like this, X, Y, Z, W, I look from the left to the right. Do you guys agree? And my K-map in this case will be what? 2 variable here, 2 variable there. Why? Because this table is covering how many minterms, how many states? Huh? This table is covering how many states?
16.
What?
12.
Hello?
Would it be 16?
Why?
2 to the 4?
Yes. So here, 1, 2, 3. 1, 2, 3. Right? So now I have what? I have the combination, which is basically what? 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So it's gonna be the same thing. 1, 1, and then 1, 0. So what I did here, I'm gonna do it there as well. So we're gonna start moving a little bit. Why? Look, 0 location, 1 location, 3 location, 2 location, right? Then 4 location, 5 location, 7 location, 6 location, and then look, 8, 9, 11, 10, then 12, 13, 15, 14. Did you see it? Why? Look, 1, 0, 0, 0 is what? 1, 0, 0, 0. This is what? Somebody can tell me what is the equivalency of this? 8. Right? Look at there. 1, 1, 0, 0. 1, 1, 0, 0. This is what? 12. That's why this 12. Make sense? Hello?
Yes.
Yes.
Clear? Easy peasy lemon squeezy? So in that case, let's have more example regarding the format for var. So if I have f as a function of w, x, y, z, which is written in the mean term form, I is equal 0 to 15, as we already have 16 mean terms or terms basically, and the number going to be 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14, right? Those are the big number. If you have such a kind of thing, and I'm asking you to do the traditional way of optimization, that's going to be really painful, right? But with K-map, it's going to be a piece of cake. Let's see why it's going to be a piece of cake. So in that case, I can make my own nice map like this. 1, 1, 2, 3. Here, W, X, Y, Z. I followed the rule, right? W, X, Y, Z, right? Now here we're gonna be what? 0, 1, 3, 2, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. And then I have here 1, 0 to make it what? 4, 5, 7, 6, right? And then I have here what? 1, 1. So if I have 1, 1, that means gonna be 12, right? So 12, 13, 15, 14. And then I have here what? The last option, which is gonna be 1, 0. So here we're gonna be 8, 9, 10, 11, right? Now we're gonna fill the gaps, right? So 0 is coming here, 1 is there, 2 is there, 4 is happening, 5 is happening, 6 is there, 8, 9, 12, 13, 14. So those are the all possibilities that I have in the K-map, right? If I put here 0, 0, 0, 0, 0, I can start working on it, right? So rule number 1, we are looking for grouping what? Ones, something 2 power 1, right? So 2 power 1 can be 2 power 3, right? 2 power 3 is 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8. Good. Group 1. Do you guys agree? Now, those 3, we cannot group them like that. So do you guys have an option? What should I do? Tell me an idea.
Put them
What
in
should
2
I do in
groups.
this case?
Two groups of 4?
Group 4. Yes, you're right. But why?
Because you have to capture all
As
3 of
many
them,
as I
but you
can.
can't do it in
Yes,
nobody
you're right.
group.
So everybody agree with her? So again,
Yes.
same thing, spherical, or I call it Alaskan United States. In that case, I take this 2 with this 2, right? And that will be my group what? Then I just have 1 there by itself, but I can also do the same thing here and there, and they're gonna be group 3. And then I grouped everything. It makes sense to everybody? Hello?
Yes.
So I can come and say that, f as a function of w, x, y, and z is equivalent to group 1 or with group 2 or with group 3. Let's write it together. So group 1, those are changing, so basically are out of my scope. The only thing I'm gonna look here, right? And I find here this is y complement is gonna be y complement. Make sense? Now we're gonna go in the second group. Second group is looking into the horizontal and vertical, right? So horizontal wise, I'm going like this. So pretty much I'm talking about what? W complement. And vertical wise, I'm talking about what? Z complement. Then I will look to group what? Group 3. In a group 3, if I look, I will just look into this with this one. So pretty much I'm talking about, here's X. And then, I will use the same color for looking in the top here. So it's gonna be what? It's gonna be Z complement. Scheiße, sorry. So all of these elements, it was in the table, within like maybe a minute, drawing and placing the numbers inside the table in the right way on the map, we figure out how to make optimization faster than applying all the postulates and what's called the De Morgan theorems and all these things to get the right answer. So that's actually a very, very good improvement from taking 15 minutes for optimizing something to like a few seconds or maybe a minute to get the right optimization. Any question regarding this specific problem?
What did you do on the first one, the group one? Could you go over it real quick?
Sure. So group one, those are 8, right? Like this.
Yes.
You agree?
Mm-hmm.
We said, I'm looking horizontal and I found them what? Changing, right? They're not count anymore, as we did in the 3 and 2, right?
Mm-hmm.
Now I'm looking in what? In a vertical. In a vertical, I'm looking here and I'm looking there, right? When I look, I found that, Y complement, here Z complement, and here's Z. So Z is out. The only one is still there is what? Y complement, because it's what? Same. So here is actually Y complement.
Oh, so the 4 like cancels each other out on the horizontal. Okay.
Same thing in the 3 var. If you understand 3 var, you will understand the specific part. Now, let's have a little bit fun. So the same problem, we'll do it again. 1, 2, 1, 2, and it was W, right? Let's do the same thing. Let's be consistent. So going to be WX, Y, Z, right? Going to be 0, 0, then 0, 0, 0, 1, 1, 1, 1, 0. So going to be 0, 1, 3, 2. And then 0, 1 like this. Going to be 4, 5, 7, 6. And then 1, 1 is going to be here 12, 13, 15, 14. Then 1, 0 is going to be 8, 9, 11, and 10. Right? Look what I'm going to do here. I'm going to actually write in a different color. So going to be here 1, 1, 1, 1, 1, X, 1, 1, 1, 1, 1, X, X. You know what? No. Put here 0. So what should we do now? How I'm gonna group it?
Can you make both of them ones? The X is 1, then you group.
You're right. It's not can you. We have to. You're right. If I'm looking to optimization, it has to be considered 1. Why? Because it's actually completing the set of 8 as a group, right? So in this case, group 1 will come again, right? What about the other X? What should I do with?
If you make it 1, it'll be easier, I think.
Yes.
Yeah, if you make,
you think why?
Because you can connect the 0, 0 and the 1, 0.
If I put here 1, then I can do like this.
Yeah.
And that will be group 2. It makes sense to everybody?
Yes. How about if you just group the last column only? Can you just, because there's 4, right?
But it will not give you a full optimization.
Yeah, you want to go with the highest.
The highest optimization.
The highest neighboring. Okay.
Yes. You squeeze it as much as you can.
Okay.
Make sense?
Yes.
Okay, so in this, group 1 and group 2 are the answer, and group 1 in this case will be Y complement, and group 2 in this case will be Z complement. And then X and W is actually what? Out. Make sense? What about this?
Professor?
Yes.
I have a question. Why couldn't we replace both X by Y by 1?
Why X by 1?
Yeah, like the X at M5 if we replace it by 1, we still could have grouped it into one thing and still have to.
1 second, I'm sorry. This one you want me to put a 0, right?
1 instead.
Yeah, I put it 1.
Oh, okay.
Okay, so it's
Yeah.
already 1 now.
Okay.
That's why we got the group 1, right?
Yes.
Okay. Anyway, so what was your question?
Oh no, in my head I didn't see that was 1. I don't know why. That was what I was.
No, that's fine. That's fine. Anyway, now we gotta play in a different way, which is basically like this: W, X, Y, Z. Sorry about that. So tell me, what should you do?
Group the top and then put another group on the bottom with the top.
I'm gonna consider all the X1, right? Because if I do it, then I will take those together, right? As a group 1. Then I will take those as a group 2. Make sense?
Could you make it so that it's XNOR on the top?
Yeah, you want XNOR?
Yeah, if you make the XNOR on the top, right? If you put one on the 0, 0, and then 0, yeah, so it would be 1, 0, 1, 0, and the second row will be 0, 1, 0, 1.
Yeah, I understand what you say, but this is what I'm giving you is the best optimization. Basically,
Oh, gotcha.
you want you cannot leave that one by itself. You have to make it with the more efficient way. So the way that putting all X by 1 is actually made me put this one and this one together in a big group, right?
Mm-hmm.
Then that X also was helping with just 3 X's, helped me to group those 2 ones in a bigger group as well.
Okay.
Right?
Yeah, got it.
Okay, thank you. Anyway, what about if I do it like this? W, X, Y, Z. Okay, and then I put it like this. What should I do? You know what? Wait. Let me be even evil. Go ahead. Tell me, what should I do?
Put ones on both axes and group the left side with the right side, like the top left.
Yes.
And then group the middle.
Yes. So
three
that
groups.
X, it has to be 1. Why? Because this together.
And can you group the 4? Can you group the 4 corners together?
Yes, because it's like a ball, right?
Yes.
It's connected, right? So this is actually
Nice.
this group 2 and this group 1.
Wait.
Huh?
You're just folding the paper back.
1
and connecting it.
2. I'm trying to figure out what kind of fold this would be.
It's a ball.
I just want you guys to enjoy the playing with this. It's really fun. Don't be afraid about exams and stuff like that. My exams are really a piece of cake. I'm not tricky. Okay? Or I hope so that I'm not tricky.
Well, this seems a little tricky, so I don't know. Is this an exam problem right here?
I remember one of my question, people didn't even find in internet. It was just made up, But anyway, so because I think they were looking in internet. I don't know. I think so. But anyway, let me find you more stuff. Honestly, the rest of the chapter is just up, basically practicing, you just practice.
Professor,
And we went
could
through
you
all of the
repeat
conversions.
something?
So actually, we are done with the chapter.
So, Professor, if you put like on the left column, if you put 1, 1 on the missing ones, would you group those two separately then?
Like this?
Yeah.
Yes.
Then
You have to do it like this.
Gotcha.
Wait. Yeah, you have to do it like this. Or what? Huh? Or like
I was gonna just group. Yeah, I was gonna just group that. Okay.
So both solutions are correct. Yes.
Okay. Cool.
That's why I'm telling you, digital logic design, you have infinite solutions, and all of them are correct.
Nice.
So my solution is correct. Your solution is correct. But who is in the middle between us? If I told you that, it has to be for power, for instance, or it has to be to be really high speed circuit, or it has to be less resources circuit, and so on. Then, I downsize number of solutions.
Gotcha. Because it depends on, at that point, it'll be like depending on the gates.
Yes. So let's have the 1, 2, 3, 4, 1, 2, 3. And then like this, W, X, Y, Z. And then let me think. Let me find you some fancy question. I like fancy questions. Okay, that's really cool. Okay, what about this? Do you have an idea? What should we do?
Oh, that's a checkerboard.
Yes. So this is basically the W, X, Y, Z.
And then the inverse of that is X NOR.
Exactly. Yes. Okay, Luke. I think we can stop here, and we can practice one more or two problems before I will move to the next chapter. But my whole sincere advice, please, just promise me to do what? Huh?
Practice.
Exactly. You have to practice. You have to practice and make mistakes and come and ask. You know what I mean? There is no shame to make mistakes. Part of the learning curve is to make mistakes, and you learn from your mistakes, right? When I was exactly in your age, I was like, making mistakes and learning from professors, and of course, we have like TAs and stuff like that. It was a social school, so we're doing a lot of stuff, and then after that, move forward, right? So there is no shame. You guys know my office hour, right? Hello.
Yes.
So my office hours Monday, Wednesday, right? So if you have any questions, keep practicing, keep making mistakes, and keep writing like list of the stuff you need to check with me, and then I check with you. I want all of you to succeed, right? So do your best, please. Help me, and I will help you more. Okay, Luke. Any question? Did you guys make the homework for the last lecture? You forgot about the homework? Hello. What was my homework?
You mean this one or the last one?
I had a homework last lecture. Did you have a chance to check? Huh?
No, I did. No, I didn't. I'll be brutally honest.
Okay. That was the last lecture.
Oh, it was doing the postulate of the truth table.
Yeah. See? There,
that
right?
one.
Work on that, okay? Okay, so it was my pleasure to talk to you today. Feel free to ask any question anytime, and I will be more than happy to assist you. And let's talk on Monday, right? Yeah, Monday. So I wish you a wonderful weekend. Okay, stay safe and God bless you.
All right. Have a good one, Professor.
You too.
Have a
Thank
good
you.
one.
Guys.
Thank you, Professor.
Thank you. Bye-bye.
Professor.
Yes.
Thank you, Professor.
So I'm understanding the concept, right? But like, how is this going to be used in real life applications?
What happened?
Like, how is this going to be used in real life applications? Like,
I'm having... we will see that. We will see that in the next few chapters. So chapter 4, the one I will start on Monday, and chapter 5 and 6 and 7. Yes.
Because so far we've just been doing tables with ones and zeros, so I'm just kind of like,
this is not the course. This is just the techniques we're gonna use later for the bigger stuff.
oh, okay.
Okay. So
Okay.
I want you to be strong in this, and then we will move forward with more complicated stuff.
Yeah, because I'm having a hard time visualizing how this would be used. Like,
No. Don't worry. You will see. You will appreciate it later.
I will. All right.
Okay. Thank you.
Yeah.
Have a good one. Stay
You
safe.
too.
Thank you. Bye bye.